C++ is a general-purpose programming language. It has imperative, object-oriented and generic programming features, while also providing facilities for low-level memory manipulation. It was designed with a bias toward system programming and embedded, resource-constrained and large systems, with performance, efficiency and flexibility of use as its design highlights. C++ has also been found useful in many other contexts, with key strengths being software infrastructure and resource-constrained applications, including desktop applications, servers, and performance-critical applications. C++ is a compiled language with implementations of it available on many platforms and provided by various organizations, including the FSF, LLVM, Microsoft, Intel and IBM. C++ is standardized by the International Organization for Standardization, with the latest standard version ratified and published by ISO in December 2014 as ISO IEC 14882-2014. The C++ programming language was initially standardized in 1998 as ISO IEC 14882-1998, which was then amended by the C++ 03, ISO IEC 14882-2003 standard. The current C++ 14 standard supersedes these in C++ 11, with new features and an enlarged standard library. Before the initial standardization in 1998, C++ was developed by Bjarne Stroustrup at Bell Labs since 1979, as an extension of the C language, as he wanted an efficient and flexible language similar to C, which also provided high-level features for program organization. Many other programming languages have been influenced by C++, including C#, Java, and newer versions of C. History. Bjarne Stroustrup, a Danish computer scientist, began his work on C++'s predecessor, C with classes, in 1979. The motivation for creating a new language originated from Stroustrup's experience in programming for his PhD thesis. Stroustrup found that Simula had features that were very helpful for large software development, but the language was too slow for practical use, while BCPL was fast but too low-level to be suitable for large software development. When Stroustrup started working in AT&T Bell Labs, he had the problem of analyzing the Unix kernel with respect to distributed computing. Remembering his PhD experience, Stroustrup set out to enhance the C language with Simula-like features. C was chosen because it was general-purpose, fast, portable and widely used, as well as C and Simula's influences. Other languages also influenced C++, including Elgal 68 Ada, CLU and ML. Initially, the class-derived class, strong typing, inlining and default argument features were added to C via Stroustrup's C with classes to C compiler, CPRE. In 1983, it was renamed from C with classes to C++. New features were added including virtual functions, function name and operator overloading, references, constants, type-safe free-store memory allocation, improved type checking, and BCPL-style single-line comments with 2 forward slashes, as well as the development of a proper compiler for C++, C-front. In 1985, the first edition of the C++ programming language was released, which became the definitive reference for the language, as there was not yet an official standard. The first commercial implementation of C++ was released in October of the same year. In 1989, C++ 2.0 was released, followed by the updated second edition of the C++ programming language in 1991. New features in 2.0 included multiple inheritance, abstract classes, static member functions, const member functions, and protected members. In 1990, the annotated C++ reference manual was published. This work became the basis for the future standard. Later feature additions included templates, exceptions, namespaces, new casts, and a Boolean type. After the 2.0 update, C++ evolved relatively slowly until, in 2011, the C++11 standard was released, adding numerous new features, enlarging the standard library further, and providing more facilities to C++ programmers. After a minor C++ 14 update, released in December 2014, various new additions are planned for 2017. Etymology. According to Strauss-Strupp, the name signifies the evolutionary nature of the changes from C. This name is credited to Rick Masher T and was first used in December 1983. When Masher T was questioned informally in 1992 about the naming, he indicated that it was given in a tongue-in-cheek spirit. The name stems from C's ++ operator and a common naming convention of using plus to indicate an enhanced computer program. During C++'s development period, the language had been referred to as New C and C with classes before acquiring its final name. Philosophy. Throughout C++'s life, its development and evolution has been informally governed by a set of rules that its evolution should follow. It must be driven by actual problems and its features should be useful immediately in real-world programs. Every feature should be implementable. Programmers should be free to pick their own programming style, and that style should be fully supported by C++. Allowing a useful feature is more important than preventing every possible misuse of C++. It should provide facilities for organizing programs into well-defined separate parts, and provide facilities for combining separately developed parts. No implicit violations of the type system. User-created types need to have the same support and performance as built-in types. Unused features should not negatively impact created executables. There should be no language beneath C++. C++ should work alongside other existing programming languages, rather than fostering its own separate and incompatible programming environment. If the programmer's intent is unknown, allow the programmer to specify it by providing manual control. Standardization. C++ is standardized by an ISO working group known as JTC1, SC22, WG21. So far, it has seen 5 versions of C++ released and is currently working on releasing C++ 17. In 1998, the ISO working group standardized C++ for the first time as ISO, IEC 14882 to 1998, which is informally known as a C++ 98. In 2003, it published a new version of the C++ standard called ISO, IEC 14882 to 2003, which fixed problems identified in C++ 98. In 2005, a technical report was released, called the Library Technical Report 1. While not an official part of the standard, it proposed a number of extensions to the standard library. The next major revision of the standard was informally referred to as C++ 0x, but it was not released until 2011. C++ 11 included most of the library enhancements of TR1, as well as many additions to the core language. In 2014, C++ 14 was released as a small extension to C++ 11, featuring mainly bug fixes and small improvements. The draft international standard ballot procedures completed in mid-August 2014. After C++ 14, a major revision, informally known as a C++ 17, is planned for 2017. As part of the standardization process, the ISO publishes several kinds of publications. In particular, technical reports and technical specifications are published when there is the future, but not immediate possibility of an agreement to publish an international standard. Until 2011, 3 technical reports on C++ were published. TR 19768 to 2007 on library extensions mostly integrated into C++, 11, TR 29124 to 2010 on special mathematical functions, and TR 24733 to 2011 on decimal floating point arithmetic. The technical specification DTS 18822 to 2014 was approved in early 2015, and more technical specifications are in development and pending approval.